Today we are going to continue the localization of the important gray matter areas, and in the next video we will localize the important white matter tracts. In the previous video we have learned how to localize the motor and sensory cortices, and in this video we will localize the language and visual cortices. The most important areas related to the language function are Broka, Vernik, the supramarginal gyrus, and the angular gyrus. As regard the Broca's area, do you remember the M sign? Here is the inferior frontal gyrus, and this is the characteristic M configuration of its shape, which is formed by the rami of the sylvian sulcus, the anterior ascending and the anterior horizontal rami. As you see, it is divided into three parts: pars orbitalis, the pars triangularis, and the pars opercularis. The pars opercularis is the Broca area. This area is responsible for the formation or the production of speech. I mean that it acts as a command center for the muscles that are responsible for speaking. So if it is injured, for example, by a neoplastic or a vascular insult, the deficit will be called motor aphasia. I mean that the speech will be non-fluent, but there is no problem in perception. The patient can understand your speech and your orders well. I think this area is easy to be localized, as it is the posterior limb of the M. For example, we can see it clearly here in the sagittal MRI and also in this axial MRI. So let's transfer to the area which is responsible for the understanding of the heard speech, in other words, the perception of speech, which is called the Vernik area. It is located here in the posterior part of the superior temporal gyrus. As I said, it is responsible for the perception of speech. So if it is injured, the patient will not be able to understand your speech or your orders, but he can speak fluently. If you remember, we have mentioned in a previous video another gyrus responsible for speech perception. It was found under the urion of the parietal eminence. Yes, right. It is the supramarginal gyrus. So there must be a direct connection or a direct relationship between the Vernik area and the supramarginal gyrus because their functions are complementary to each other. This is logic, right? The supramarginal gyrus, as its name refers, is superior to the margin of the sylvian sulcus. And this gyrus needs to fuse with the Vernik area. To do that, it must curve around the sylvian sulcus, taking the U shape around the posterior end of the sylvian sulcus. And this is what already happens indeed. Look to this sagittal MRI view. This is the posterior end of the superior temporal gyrus or the Vernik area, labeled in turquoise. And this is the sylvian fissure, labeled in red. There is a gyrus taking a U shape, lightened in blue, curving around the sylvian fissure, fusing with the Vernik area. It is the supramarginal gyrus. Now let's transfer to the angular gyrus. This gyrus is the young brother of the supramarginal gyrus. It sits close to it and even resembles it in the shape and also in the function. As the supramarginal gyrus curves around the sylvian sulcus, the angular gyrus curves around the superior temporal sulcus. So it nearly takes the U shape like his old brother. Look to this sagittal MRI image. This is the angular gyrus beside the supramarginal gyrus. The function of both of them are nearly similar, and we can make it easy to remember their close functions through this very simple concept. The supramarginal gyrus receives the language in the form of letters, while the angular gyrus receives the language in the form of numbers. So if the angular gyrus is injured, it will result in a form of sensory aphasia characterized by difficulty in identifying and calculating numbers called calalculia, which is considered a part of the Gertzmann syndrome. So we have met the area of speech understanding and also the area of speech production. They are away from each other, but there must be a direct connection between both areas through a white matter tract or a fascicle. Because this fascicle connects the superior temporal gyrus to the inferior frontal gyrus, it must take the shape of an arc. So it is called the arcuate fasciculus. We will discuss it in more details in the next video about the localization of white matter tracts. If you notice, we have finished the inferior half of the parietal lobe because the supramarginal gyrus and the angular gyrus are collectively called the inferior parietal lobule. So the remaining part, which is the superior half, is called the superior parietal lobule. This lobule is mainly responsible for the spatial perception of the whole body. In other words, it knows the exact location of the limbs and the trunk in the space. So if this lobule is injured, the problem, of course, will be the hemi-neglection. Here we have a little but useful note regarding that lobule. Look with me. To be oriented by the spatial position of the body, this lobule needs to be immediately and continuously informed by the sensory data in general and the visual data in particular, and this needs a direct connection between it and the sensory cortex as well as the visual cortex respectively. Is there a connection between it and the sensory cortex? Yes. Let's revise the axial image. This is the central sulcus. The precentral sulcus and the postcentral gyri are seen. Look to this bridge. It connects the postcentral gyrus to the superior parietal lobule. This is the necessary connection between them, which makes the superior parietal lobule continuously informed by the general sensory data. Once you see this bridge, you can localize the superior parietal lobule easily. Now let's see its connection with the visual cortex. But at first, we should localize the visual cortex. Look to this sagittal MRI view. The visual cortex is the occipital lobe. It is separated from the parietal lobe by the occipitoparietal sulcus, which is labeled here in a purple color. This part of the visual cortex is called the cuneus. It takes its name from its shape, as it is shaped like a cone, which means that it must be located between the short arms of the capital letter Y. This is the first arm, the parieto-occipital sulcus, and here is the next arm of the Y letter, the posterior end of the calcarine sulcus. The calcarine sulcus is easily identified as it goes anterior-inferiorly to end under the splenium of the corpus callosum, or in other words, in the pineal region, which makes it a natural surgical corridor to this region due to its wideness. So, do you see a direct connection between the superior parietal lobule and the visual cortex? Yes, here it is. They are very close to each other, the same way between the lobule and the sensory cortex. In this way, the superior parietal lobule becomes continuously capable of spatial orientation. Now we have reached the end of this video. I hope that was helpful. See you in the next video, and thanks for watching.